Alright, in the first example for writing total and net ionic equations, we're going to look at the reaction between lead chloride and sodium sulfate. So our first step whenever we are writing net ionic equations is we first need to make sure that our equation is balanced. So since we've had lots of practice with that, I'll just be able to do that quickly. We're going to need 2 sodium sulfates and 4 sodium chlorides. So now we have a balanced equation. 1 lead chloride reacts with 2 sodium sulfates to produce 1 lead sulfate and 4 sodium chlorides. So that's going to be our balanced equation. Now our second step is to create a total ionic equation by breaking the aqueous compounds down into their ions. So note when it said aqueous, that means the AQ, 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 aqueous. We will not break down the lead sulfate because it's a solid. So we'll just take it one compound at a time and write out the complete total ionic equation. So we will have lead with a 4 plus charge and 4 chlorine ions with a minus charge. Again, there we could figure out the charges there because we know that chlorine is always going to have a charge of -1, and then we know that lead is a multivalent metal, so if there's 4 chlorines there has to be 1 lead with a 4 plus charge. So it's kind of like the opposite of the crisscross rule from Unit 1. And then we'll move on to the sodium sulfate. So we're going to have 4 sodium cations, and the reason why there's 4 is because, see there, that subscript 2, 1 molecule of sodium sulfate has 2 sodiums, and we have 2 molecules of it. So we have to multiply the subscript by the coefficient. That gives us the 4 sodium cations. And then we'll have 2 sulfate anions. And again, the charge on that, the sulfate, you can find that on the common ions chart. So that's the left side of our reaction equation, and then we had solid lead sulfate form, and for that one we do not break this one down because it's a solid. We only break down aqueous compounds. And then our final, that's going to be on the left side of the equation, or on the right side rather, is we're going to break down the NaCl. And because there are 4 sodium chlorides, then we know we're going to have 4 sodiums and 4 chlorine anions. And again, I'm just writing it like this for the sake of room on the screen here. So we have broken down all the aqueous compounds into their component ions, and that right there, we form the total ionic equation. So now our third step is going to be to cancel out all the spectator ions. And what spectator ions are, those are the ions that appear exactly the same on both sides of the equation. So if they're the same on both sides of the equation, we cancel them out to write the net ionic equation. They're called spectator ions because it's kind of like, oh, they're just spectating. If they're the same on both sides, they're not really reacting. That's kind of the logic there. So I'll look at this and I'll think, okay, well, I see that there's 4 chlorine anions here and 4 here. So we can go ahead and cancel those out. And then I see that there's 4 sodiums here and 4 sodiums there. So we can go ahead and cancel that out. and then we'll look. So lead is on the left side, but there's no lead ions on the right side. And then we have a sulfate ion on the left side, but none on the right side. So our final step here is just to write down what's left for the net ionic equation. So in terms of what's left, we have the lead, we have the sulfate, and we have the lead sulfate solid that gets formed. So that makes the net ionic equation in this reaction the lead 4 plus, the aqueous lead 4 plus, one of those, with 2 sulfates, giving us 1 solid lead sulfate compound. So that is our net ionic equation for the reaction between lead chloride and sodium sulfate. Now we're going to look at another example. So in this example, we're going to look at the reaction between chloric acid and calcium hydroxide to form calcium chlorate and water. So this is actually a neutralization reaction, as we're going to learn very soon in the solutions unit. So the steps that we need to take here to solve this are going to be the same as the previous example. Our first step is we're going to have to make sure that our equation is balanced, and I'll just do that quickly since we've had lots of practice with balancing. We balance this by having 2 chloric acid molecules and then 2 waters. So now we have a balanced equation. Our second step is that we're going to break down the aqueous compounds into ions. So just the aqueous compounds, not anything that's solid, liquid, or gas. So we'll start from left to right. We are going to have 2 H plus ions and 2 chlorate anions. Again, the reason why we have 2 is because there's 1 polyatomic chlorate and 1 hydrogen in 1 compound of chloric acid, and we have 2 molecules there because we have that coefficient. So there are 2 H pluses and 2 chlorates, and then we'll move on to the next compound, which is the calcium hydroxide. So we're going to have 1 Ca2 plus. Again, we know the charge of calcium is 2 plus from the common ionic states of the elements. And then we have 2 hydroxide anions. And again, the charge on the hydroxide, we can determine that from the common ions chart. And we know that there's going to be 2 of them because there's that 2 subscript right there. And then we're going to move to the right side. So we will see the calcium chlorate. We're going to have 1 calcium cation being produced there. And we're also going to have 2 chlorate anions being produced from the calcium chlorate. Again, there's got to be 2 because we have 2 of the polyatomic chlorate ion. So there's 2 of them there. And then our last piece there on the right side will be the 2 water molecules that we have that are liquid. And we don't break up the water because it is a liquid. So we're not going to break that up. All right, step 1 and 2 are done. Now we are going to cancel out the spectator ions. So what are the ions that are the same on both sides of the reaction equation that seem as though they don't really participate? So I can see we have 2 chlorates on the left side and 2 chlorates on the right. I can see we have a calcium cation on the left and a calcium cation on the right. And then let's just go back and look through here. So we have the 2H plus, there's nothing on the right side, the 2OH minus, and there's nothing identical on the right side, and the left side also doesn't have the water. So with that, we pretty well identified what our main ions in the net ionic equation are. And then we can use that to rewrite our net ionic equation. So the net ionic equation here is going to end up being 2H plus. Remembering we have the aqueous subscript because everything is aqueous in this situation. Plus 2 hydroxides will yield 2 waters. So that is our net ionic equation for this reaction. And then just as a fun fact, as a preview to a future lesson, this is a neutralization reaction between an acid and a base, because calcium hydroxide is a base and chloric acid is an acid. The net ionic equation here for 2H plus and 2OH minus giving you 2 waters. The net ionic equation for really any neutralization reaction is going to look like some number of H plus OH minus gives you water. So the general form of that, just for future knowledge so that we have a bit of early exposure, is always some form of H plus OH minus yields water. So that was our second example. And again, what we did, we just looked for how to balance our original reaction equation. We broke down each compound into its component ions, and then we crossed out the spectator ions, so it's the same on each side. Then we looked for what remained after we canceled out the spectator ions, and then that became the net ionic equation, which is circled here.